Hello, and welcome to this breakout session. I'm Jason Hansen, one of the program managers for Azure Arc. Now, I'm excited to join you today to dig in and explore extending Azure management and services anywhere. We've got a few announcements, and I've got a couple of demos to dig in and show you how this stuff works. So first, Azure takes a comprehensive approach to the hybrid landscape, offering a unique set of capabilities that provide flexibility for customers to innovate across multiple form factors and locations. For example, Azure Stack portfolio brings Azure consistent infrastructure to your own data centers with Azure Stack Hub, or it can even run on existing certified hardware using Azure Stack HCI. Now, Azure IoT brings Azure capabilities to small form factor devices and sensors at the edge, providing Azure consistent management experiences and tooling for operators and developers. Now, Azure Arc extends Azure management capabilities anywhere, connecting the Azure control plane in the cloud to infrastructure that runs in your existing data centers, edge locations, or other cloud providers. And Azure Arc also makes it possible to run some Arc-enabled services in your data center. So let's go ahead and dig in and look at three key scenarios that Azure Arc enables. Now, first is organization, inventory, and governance. Azure Arc allows you to attach and manage your IT assets in Azure. Servers and Kubernetes clusters that are in your own data centers or edge locations, or even on other cloud providers, can sit side by side with the resources that are running on Azure infrastructure. And you get to use the same APIs, CLIs, and portal experiences no matter where those resources are running. Now, this also extends beyond visibility in the portal too. Other Azure integrated services like Azure Monitor, Azure Defender, or Azure Policy can now control and govern those resources that are running in your own data centers. Now, second, for customers who are investing in container-based applications running on top of Kubernetes, Azure Arc brings a set of capabilities that are container native. So those management experiences include Azure Monitor for containers, a GitOps-based configuration application deployment service, as well as monitoring and logging from Azure Monitor. So even better, developers who are using those Kubernetes native APIs can use all of their existing build pipelines, their container images, their Helm charts, their Kubernetes manifests with little to no change. Because if you've taken a bet on the Kubernetes ecosystem, Azure Arc wants to help you scale those investments to tens or hundreds of clusters with just a few clicks. Now, many of the management services that I've talked about are hosted on and run on Azure infrastructure. Now, this last scenario is particularly important as customers can now run some Azure services in their own environment through Azure Arc. Azure Data Services, for example, is one of the first Arc-enabled services which delivers SQL-managed instance and Postgres hyperscale to your own infrastructure. And this is great for customers with latency-sensitive requirements, data sovereignty concerns, or have an existing data gravity on premises that they need to deal with. Azure Data Services allows customers to gain the benefit of the database as a service capabilities that they enjoy on the Azure platform while running that on their own infrastructure. Now, with those three key scenarios under our belt, I want to talk about a few announcements. First, I'm excited to announce that Azure Arc-enabled Kubernetes is now generally available, joining Azure Arc-enabled servers. Now, with broad Kubernetes distribution support, Azure Arc-enabled Kubernetes and Azure Arc-enabled Server meets you where you are with your existing investments. Customers can manage the Windows and Linux servers sitting right next to their Kubernetes clusters, all from a single Azure interface. Second, I'm also happy to announce that Azure Machine Learning is now Azure Arc enabled and in preview. As the newest addition to the Arc enabled set of services, customers can now use Azure Machine Learning to deploy and manage training workloads to either compute that's registered on Azure or compute that has been Arc enabled running in their own infrastructure. Now, stay tuned, and we'll see a demo of these new capabilities a little bit later on in this session. So let's go ahead and jump in and take a look at Azure Arc from the top. Now, I recorded our first demo a little earlier, and it digs into organization, inventory, and management services, through the lens of a customer, Contoso Renewable Energy. Let's go ahead and roll the demo.
Contoso Renewable Energy operates a globally distributed infrastructure with applications, servers, and containers deployed to multiple locations, including private data centers, edge sites, and cloud providers. Now, Contoso's existing IT management experience crosses multiple organizational boundaries, disparate tool chains, and different infrastructures. Seemingly simple tasks like answering inventory questions or ensuring OS updates are rolled out can be extremely time-consuming and complicated. In addition to existing IT management needs and processes, new initiatives like cloud-native application development, data governance, and machine learning are in development and critical for the business. Now let's see how Contoso has used Azure Arc to bring consistency to their hybrid environment. Here, we are in the Azure portal, viewing one of Contoso's subscriptions and resource groups. Contoso's environment consists of physical and virtual servers and databases located in data centers, as well as a few Kubernetes clusters running containerized applications deployed at edge sites. Contoso has Arc-enabled this infrastructure, and unlocking the Azure portal, Azure CLI, DB tools, and APIs as a consistent set of management experiences across all of these resource types. Now, because these resources are surfaced in Azure, Contoso can use all the organization and inventory capabilities. We can group resources into resource groups, apply tags, and use Azure role-based access control to define who can and can't see these assets. Let's dig into one of these Arc-enabled servers. Now, this server is running in one of Contoso's data centers, but can be managed from Azure. Here we see operating system and computer information, and can see that the server is connected. Contoso has also tagged this server with information about its physical location and cost center, which allows Contoso admins to quickly search across their entire inventory, both cloud and on-premises. Now, Azure Arc also helps IT admins opt in to additional Azure services. Enabling Azure Monitor for existing servers is easy. Azure Arc downloads, installs, and configures monitoring and logging from the cloud. And Contoso admins no longer need to be on the same network, building, or continent to administer their servers. This saves tons of time and headache. Now, security is also important to Contoso, and this server is monitored by Azure Defender, which continually looks for configuration recommendations and security issues. The server lives in the data center, but through Azure Arc, Contoso can quickly and easily use these Azure-hosted capabilities. No need to migrate the server. Now, Azure Update Management also helps Contoso keep all their servers up to date. Now, Azure Update Management identifies servers with missing updates and schedules installation when it's least disruptive. Contoso also collects software versions, running services, and file inventory across many servers. Now, change tracking watches that inventory over time, and it gives server owners visibility into when and how their servers change. Contoso also uses this information to track licensing cost, identify old software versions, and gain visibility into configuration updates. Now, Azure Arc also brings Azure Policy to Contoso's servers. Using Policy, Contoso audits operating system settings for both security and operational requirements. For example, Contoso automatically audits strong password requirements, expiring SSL certificates, and requires monitoring for all their servers. Contoso is using the exact same policy engine they are using on Azure today. The same policies work across any Azure Arc-enabled server and Azure Virtual Machine. Contoso Renewable Energy has a single management experience for audit and compliance across their entire organization. Contoso also has significant investments in SQL Server. Now, by using Azure Arc technology for servers, Contoso now has full visibility into those Azure Arc-enabled SQL servers without needing to migrate any databases. It can see each on-premises database in Azure, group by resource group, tag, and query across their inventory. Now, Azure Arc-enabled SQL Server also deeply integrates with the Azure Security Center to enhance security posture for on-premises SQL Server using the latest innovations from Azure. Contoso can run vulnerability assessment and enable advanced threat protection from Azure Defender. Now, across Windows, Linux, SQL Server, virtual machines, and physical hosts, Azure Arc brings the power and capabilities of Azure to Contoso's hybrid environment. Now, even better, when Azure adds new services, features, or improvements, Contoso automatically benefits.
Welcome back. Now, a quick recap. Contoso Renewable Energy has Arc-enabled set of resources running across multiple locations. This includes Windows servers, Linux machines, SQL servers, and Kubernetes clusters. Now, Azure Arc connects those resources to the Azure platform, enabling a whole host of management services to target that infrastructure. Now, this is also a scenario that Microsoft is using itself to manage SSL certificates for servers that aren't running on Azure infrastructure. Now, our Microsoft IT team has Arc enabled over 17,000 servers and uses that Azure Arc capability to connect those servers to Azure Key Vault. They can pull down and keep certificates up to date for these machines across the entire infrastructure. This is all, again, driven through Azure APIs, and those machines are running in lots of different locations. So up next, I'd also like to dig in and take a look at Azure Arc-enabled Kubernetes in a little more detail. Let's see how Contoso Renewable Energy is tackling container-based deployments to many of their edge sites.
Let's look at a new container-based application that Contoso Renewable Energy is developing and deploying to multiple locations. Now, Contoso is using containers because they know they will need to run multiple apps at each site. And Contoso is also using Kubernetes to host those apps deployed to those locations with varying hardware configurations. Now, due to data latency reasons, the application data collected from machinery in the field needs to be persisted locally. And optimizing for consistency and productivity, now Contoso is chosen to run that data workload using Azure Arc-enabled SQL-managed instance, which brings cloud platform as a service benefits and a cloud-based billing model to on-premises data workloads. Now, data is stored at each site for local processing and visualization and can optionally be brought back to Azure when connectivity is available. Now, given this is the same evergreen SQL-managed instance from Azure, the database is automatically updated and patched without end of support, as in typical on-premises data solutions. Now let's head to the Azure portal and view Contoso's infrastructure. Now, in this resource group, we have Kubernetes clusters running in a data center, another running on a cloud provider, and a few sites, including one running AKS on Azure Stack HCI. Now, each of these clusters have been Arc-enabled and are visible to Azure. And like we saw earlier, these clusters can be grouped, tagged, and searched just like any Azure resource. Now, Contoso's wind farm application is deployed to each of these clusters. And using the new connected mode for Azure Data Services, Contoso can deploy SQL-managed instance either from the Azure portal to each local cluster and manage their database instances from Azure. They can use familiar tools like Azure Resource Manager, using ARM templates, native Kubernetes tools, or even the Azure Data CLI. Now, with many sites, Contoso needs to ensure that their clusters are configured consistently and that their applications are kept up to date. Now, Contoso is using GitOps capabilities of Azure Arc-enabled Kubernetes to deploy their applications and the SQL-managed instances. Now, for those who aren't familiar with GitOps, Contoso cluster administrators define how they want their clusters configured. They check that definition into source control and apply that configuration across their clusters. Azure Arc uses Flux, an open source component from Weaveworks, to clone the repo, apply any resources, and keep that cluster up to date. Now, let's take a look at this AKS instance running on an HCI cluster and drill into its GitOps configurations. Contoso cluster admins have defined the baseline configuration for their cluster and are also deploying that wind farm application. Now, this baseline config contains all of the Kubernetes resources and setup that Contoso needs on each of their clusters. It's worth noting that any valid Kubernetes resource or Helm chart can live in this repository and be automatically applied to one or hundreds of sites. Now let's look at the actual Git repository containing this baseline configuration. Now, Contoso happens to be using GitHub for source control, and cluster administrators have defined a few namespaces and some RBAC configuration. Now, it's important to call out that any Git host may be used just as long as the Kubernetes cluster can reach that service. The repository could be another cloud-hosted solution or a private Git server run by Contoso IT. Using a GitOps-based workflow, cluster administrators make configuration changes by opening a pull request. Now, in this pull request, cluster admins are onboarding a new team by creating a new namespace and associated RBAC bindings. This repository also uses GitHub Actions to test updates before merging to the main branch. And this action checks resource syntax to catch typos early, but Contoso has full flexibility to add and remove checks to meet their business requirements. The pipeline can be as simple or as complex as it needs to be. Now, this workflow is also used by Contoso developers. And you remember that wind farm application, which is also deployed using GitOps. Let's actually look at the AKS and HCI Kubernetes cluster and see our deployed app using kube control. Now, because these capabilities use standard Kubernetes APIs, the ecosystem tools and techniques are all available to us. Here, we see our SQL managed instance pod sitting right next to our wind farm application. And we can also see the Azure Data Services data controller, which is responsible for managing the database instance running in this same cluster. Now, let's go ahead and head back to GitHub and see what it looks like for a Contoso developer to update and deploy their application. Now, this is the repo for the wind farm application. It contains everything necessary to deploy the app. And the Contoso dev team has access to this repo, and they are able to add, update, or remove application resources as needed. Now, all their Kubernetes resources are checked into this repository. Now, while the dev team has full control over their application, cluster administrators have used Azure Arc configuration management to ensure that the developers may only deploy to a dedicated namespace. And just like the cluster administrators, our devs open a pull request to ship their changes. Now, this pull request bumps to a new version of the application. And with these changes flowing through source control, change review, testing, and discussion are all tracked and visible to the whole organization. Keeping everyone on the same page has never been easier. So let's go ahead and merge this change. Now, keeping an eye on lots of applications and clusters can be a challenge. Fortunately, Contoso uses Azure Monitor, and metrics and logs are flowing up to Azure. Contoso application developers and cluster operators can see resource consumption and application logs from any of their edge locations. All of this data is stored in log analytics, which makes it very easy for application developers and cluster administrators to search and analyze their resource usage. Now, with multiple sites, clusters, and applications, Contoso needs to ensure that everything is not only configured properly, but also stays that way. Now, Contoso uses Azure Policy to make sure that their Kubernetes clusters are set up correctly. Now, this policy-based configuration is powerful because it provides a zero-touch experience for cluster administrators. Here, we see that Contoso has configured a policy which requires our baseline cluster configuration on all clusters in this resource group. If the configuration is missing or it is removed, this cluster is flagged by Azure Policy. Admins can quickly schedule a remediation task to bring that cluster back in line. And if this is a brand new cluster registering to the subscription for the first time, well, the Azure Policy Engine kicks in and automatically applies all the necessary configurations. Cluster administrators don't even need to lift a finger. Now, Azure Arc-enabled Kubernetes brings all of Contoso's clusters into one management interface. It unifies monitoring, application deployment, and policy enforcement. The cloud-based management simplifies Contoso's operational footprint. Now, Azure Arc-enabled Kubernetes also has broad support for any CNCF conformant distribution. And we've also worked with partners to make sure Azure Arc works well with their distros, including existing partners like Red Hat, Canonical, and Rancher, as well as new partnerships with Nutanix and VMware. And importantly, Azure Arc also delivers that Azure Data Service to those edge locations, which not only helps Contoso tackle latency, data gravity, and sovereignty challenges, but also provides flexibility and choice. Contoso may also choose to deploy Azure Database for Postgres Hyperscale on Azure Arc, if any workloads require multiple worker nodes for seamless scale-out. No matter where the Kubernetes clusters are running, Azure Arc brings Azure management and services to your environment. Let's head back and see if those app updates have shipped. Now, our application containers are deployed, and our app is up to date. And this process can be repeated across 1, 10, or even hundreds of clusters.
All right, welcome back. And you may have noticed a pattern here. As with Arc-enabled servers, Arc-enabled Kubernetes unlocks many of the same management experiences. For cloud-native developers, components from the Kubernetes ecosystem, like Flux, enable developer and cluster operator experiences that integrate seamlessly with your existing tools and investments. And functionality from Azure Data Services helps customers tackle tough data management issues at the edge, whether it's latency, data sovereignty, or on-premises investments. Now, before we jump into a demo for Azure Machine Learning, I'd like to run a video from EY, one of Arc-enabled Kubernetes customers, and let them talk about, in their own words, how they're using Arc-enabled Kubernetes to tackle their own hybrid challenges.
EY created a pretty significant infrastructure across the globe, which includes 3 global data centers that are owned and managed by EY, and a significant amount of branch offices which have small data rooms. We currently have a cloud-first strategy. That means that every workload that needs to be considered or needs to go through our solutioning process could initially and by default attempt to be hosted in the cloud.
At EY, we have multiple applications running across the cloud as well as on-premises due to various compliance and regulatory restrictions on some of the tax-related applications or some of the business line applications. With the help of Azure Arc, we are able to manage all those Kubernetes clusters running on-prem or what we already have in cloud. That is something really helpful and gives us a single pane of management. Azure Arc helps us to automate some of these operations which are really difficult in case of hybrid cloud. If you look at the hybrid scenario wherein we have applications run in a VM or applications which will require databases on-prem, having Azure Arc for servers to manage the virtual machines running on-prem from Azure is really helpful. With all this, we get a central control plane, so we get a single consistent experience which will definitely help us.
So I believe that it's going to be really the cornerstone for the edge strategy. At the heart of Azure Arc, I believe there is a clear intention to extend the cloud services in places where cloud has no reach.
We are excited to see that Azure Arc has enabled us to manage existing infrastructure as well as build new apps on Kubernetes. We are looking forward to even more product innovation in this space from Azure.
Welcome back. Now, you may have noticed a pattern here. As with Arc-enabled servers, Arc-enabled Kubernetes unlocks many of the same management experiences. For cloud-native developers, components from the Kubernetes ecosystem like Flux enable developer and cluster operator experiences that integrate seamlessly with your existing tools and investments. And functionality from Azure Data Services helps customers tackle tough data management issues at the edge, whether it's for latency, data sovereignty, or on-premises data gravity. Now, up next, let's go ahead and dig in and see what Arc-enabled machine learning is all about. Sarya Das is a program manager on the Azure ML team, and I asked him to send over a demo. Let's hear from Sarya about the new capabilities from Azure Machine Learning.
Thanks, Jason. We just saw how Azure Arc-enabled Kubernetes can be used as a single pane of glass to view all your Kubernetes clusters, use Azure-based management services, and enforce policy at scale. Let's see how we can extend this to Azure Machine Learning to train models using your data that lives on your on-prem clusters. In this demo, I'll show you 2 things. First, how IT administrators can use the unified management plane of Azure Arc to provision resources with ease across on-premises and in multi-cloud. And then 2, how data scientists can utilize these resources for machine learning model training. Let's build a model to optimize energy production for Contoso that is based upon turbine and wind speed data. As Jason showed, Contoso Renewable Energy have deployed a bunch of Kubernetes clusters to multiple locations in Azure and other clouds and on-premises, including at a wind farm. We can leverage this on-premise cluster in Azure Stack HCI and use to train the model. So if you look at this Azure portal, we are looking at this specific cluster, AKS HCI, which is an Azure Stack cluster in the Contoso ML resource group, and we will use this to train our model. Now, this helps us utilize spare capacity to optimize infrastructure. It also ensures that any data Contoso considers sensitive does not leave the on-premises location and meets regulatory needs. This enables true hybrid machine learning. What I have done is I have enabled the Azure Machine Learning agent on this cluster by running a simple CLI command. I have also ensured that all the data scientists have appropriate permissions to this specific cluster. And now that the setup is ready, let's switch hats and see what a data scientist can do. I am now a data scientist in the Azure Machine Learning Studio. Azure Machine Learning helps build, deploy, and manage models and provides end-to-end lifecycle management. This studio workspace is the home for data scientist teams. Here I have my data sets, notebooks, experiments, models, and pipelines. In just a few clicks, I can attach a compute cluster that I was granted permissions to and begin using it. Let's see how we can do that. Let's go to the compute tab. Let's go to attached compute. Let's select Kubernetes service. Let's give it a name, my cluster 1. Let's select Kubernetes via Azure Arc. And then we can select the AKS HCI cluster, stack cluster, and Contoso ML resource group. And then we click attach. Now, just with this simple click, our cluster will be set up to be targeted for machine learning training. This will complete in a couple of minutes. Now let's switch to the Notebooks tab. As a data scientist, I can use familiar tools of my choice to build models. I like to use Jupyter Notebooks and can begin training a model to predict energy consumption. Now I have this Jupyter Notebook where I have prepared all the data, the turbine and wind speed data. I have set it up. Now all I'm going to do is set the compute target where I'm going to run the training job to our Kubernetes compute, and I've given it the name my cluster 1, which is the one that I just created. And with this single line of change, I'm all set to submit my training job. All I need to do is execute this cell, which runs a training job. And you can see it's gone into executing. Now let's go to the experiments tab. If you go to the experiments tab, you will see that this is the experiment and it's got multiple runs, almost 10 runs. You can see that number 10 is the one that we just submitted. It's queued, and we already have 9 of them that are completed. This job is now in queued state. It will go to preparing and then go to running and then to completed. So we just saw that with Azure Arc enabled ML, you can build models consistently and reliably anywhere. I did not need to move my data, and I leveraged my existing infrastructure. I demonstrated how this is done on an on-premise stack HCI cluster, but I can just as easily run in multi-cloud too and take advantage of Azure Arc security, compliance, and unified management. Back to you, Jason.
It's great to see Arc-enabled Azure Machine Learning bringing consistent ML training to both Azure and Arc-enabled Kubernetes clusters. And as customers onboard to the preview, I'm excited to see customers bring those Azure ML capabilities into their own infrastructure and tackle their own machine learning challenges. Now, as you can see, Azure Arc has a lot of capabilities that help you unify operations and modernize your data center through cloud-native services. Now, we have a wide ecosystem of partners that are experts on Azure Arc and can help you get going. Now, Azure Arc is very powerful, especially when paired with partners who are using Azure Lighthouse. And customers can control access delegation to their Azure subscriptions and audit all of the service provider actions. Now, this rich set of tools, which helps partners and customers stay on the same page as they plan, build, and implement their services on Azure using Azure Arc. Now, for those customers who like to get started on their own, we've got a number of places to start. First is the Azure Arc product page, which links to each of the Arc-enabled infrastructure and services portfolio. That includes documentation, how-tos, and quick starts. Next is the Azure Arc Jumpstart project, which is the easiest way to quickly set up and run various Azure Arc scenarios. And this repository includes things like ARM templates as well as Terraform examples to get you up and running quickly so you can put your hands on the technology and see how it would work in your environment. Last but not least, we have the Cloud Adoption Framework. Now, this helps organizations work through more complex projects, and the framework helps customers think through technical and non-technical considerations when managing their hybrid environment. And the framework includes reference architectures, best practice guides, and blueprints, as well as a set of learning modules that allow you and your team to get up to speed. So definitely check out these resources and get started with Azure Arc in your environment today. And thanks for joining.